we're going to begin our exploration of comparing two different proportions with hypothesis testing. So this is the instructional page for testing the difference between two independent proportions. Now, when we look at the requirements down here, we can see that there's a little bit different. So we have random, of course, because we learned a long time ago that if things aren't random, they are biased, and then we have problems, right? In particular, we have sampling bias problems. And now we have this new piece right here. So independent samples, that's new. That's the whole, there's two separate groups measured once. That's new. We haven't had that before this chapter. And then we've added a little bit here. So we have samples are independent of the population. And we've seen this before, but now we have it doubled because we need our sample size for group 1 to be less than 0.05 of the population size for group 1. And we need group 2's sample size to be less than 0.05 of the population size for group 2. So we're going to have to do those calculations twice. And then normal, same thing. We learned in chapter 8 actually that n times p times q being greater than 10 creates normal conditions for us. But here we're going to have to do it twice. We have to do it once for group 1 and again for group 2. So our requirements piece has gotten a lot larger. But remember, as usual, we only complete these if requested. We don't do these all the time. We only do them when they are asked for in a particular problem. All right. Then we have our hypotheses here. Now you'll notice there's just P1 and P2, but there's no numbers, right? That's because in this chapter, they aren't going to be equal to numbers. It's not like chapter 10. It'll just be this, P1 equals P2 for every null hypothesis, no matter what. And then the alternative will be either left-tailed, right-tailed, or two-tailed in the middle. Then the other piece I want you to notice here is in step 3, we're not going to do this by hand. We're just going to use technology, right? This is our test statistic, right? Our z-stat. So when we get into StatCrunch, we're just going to make StatCrunch, right, do the heavy lifting for us. And we are not going to do this by hand. We're not even going to substitute. We're not even going to figure out the values. All right, and the rest of it is basically the same as chapter 10. All right, so let's start putting this into practice with a big example. All right, apnea of prematurity, defined as cessation of breathing that lasts for more than 15 seconds and is accompanied by hypoxia or bradycardia, occurs in at least 85% of infants who are born at less than 34 weeks of gestation. So what we're talking about here is when babies are premature and they're little, they can have problems with breathing, right? Apnea is meaning they're not breathing, right? They're not breathing. Cessation of breath means they stop breathing for 15 seconds or more. And it creates hypoxia, it creates low blood oxygen, things like that. All right, so one therapy for this condition is to give caffeine to the premature infants. So they put caffeine in their IVs, for example. Medical researchers conducted an international study in which one sample of premature infants was randomly assigned to receive caffeine therapy and another sample received a placebo therapy. Researchers compare the rate of needing supplemental oxygen at 36 weeks between the two groups to determine whether the caffeine group would need less oxygen than the placebo group. The caffeine group included 963 infants, of which 350 needed oxygen at week 36, and the placebo group was of 954 infants and had 447 that needed oxygen at week 36. Okay, so that's a lot of information, but that's the kind of way these types of problems work, right? Because there's a lot of stuff going on here. So the first thing we want to determine is, what is group 1? Okay, so I defined here group 1 is the caffeine group. I just said it. To be honest with you, it's kind of arbitrary. Arbitrary means it's just made up. So I will just make it up for you most of the time. If I don't make it up, it means it doesn't even matter. Right? And it generally doesn't. But I just picked group 1 to be the caffeine group. So if we go in here, we can see the caffeine group had 963 infants, of which 350 needed oxygen. Okay, so remember that p hat is x divided by n. And in this case, they just have a little number 1 after them to indicate they're from group 1. Okay, so that would be x1 would be 350. That's the number that needed oxygen. The number of successes, which is 350, divided by n1, which is 963. And actually, at this case, let me just do a little quick review. Let me just make a note here. P hat is x over n. We learned that in chapter 6, actually. But let me just remind you, that's the number of successes. X is the number of successes. N is the number of, now in chapter 6 we called it trials because we were working with a binomial probability distribution. But later chapters we called it observations. It's the sample size. Okay, so that's just a little review of those topics. All right, so then let's look at P2. So P2 must be, oh, and I should label this. This is the caffeine group, just to remind ourselves. And this down here will be the placebo group, right? So that'll be X2, the number that needed oxygen out of that group, divided by N2. Well, the placebo group is right here. It had 954 infants, 447 needed oxygen out of that 954. Now, that's all well and good, but it's a little hard to compare. So I'm actually going to find these as decimal values right here with Desmos. Okay, so 350 divided by 963 gets us 0.363. And 447 divided by 954 is 0.46, well, 4686. So let me do 4 decimal places. So I'm going to write these down and then we'll go back and grab them. So 0.3634. There they are. All right, now let's look at this histogram for a second because it kind of shows us what's going on here. So this is the caffeine group over here. And you can see this is the percentage out of all the caffeine, right? There's 963 babies in here. The percentage that needed oxygen is right here. It was 0.363. And then here's the placebo group over here. And the percentage that needed oxygen out of all 954 of them, right, was 0.469. Right, that's what we found. So when we find p hat, we're finding those values. And for the record, I didn't find them, but I could, right? I could find q hat. Q hat would be 1 minus p hat, right? Oh, let me do a little note on that as well, just to remind everybody. Right? Another note, q hat is 1 minus p hat, right? Because they're complements of each other. They add up to 1. So q2 would be 1 minus 0.4686, which would be let's grab that Desmos again. And I didn't ask for this, but it doesn't hurt to know how to find it. So 4686 and then 1 minus 0.3634. So we get 6366 and 5314. Oops, I pressed the wrong button. There we go. This was what was specifically being looked for, though, so I want to circle it. And I'm just going to nudge this in here, right? So this is 0.6366. And that's this value. Or I guess I should round it to 637 since I did 3 decimal places on the other one. And this one would be 531. Just so you guys can see, this is the Q2 hat, this is the P2 hat. Right? That's what this is a graph of. Right? It's a graph of those values. And this is the P1 hat, and this is the Q1 hat. Sorry, my hat got a little lost there. All right, now, hypothetically speaking, what is the good outcome for the premature infants at 36 weeks? Okay, well, just think back to this. These are premature infants who are having trouble breathing. So they're injecting them with caffeine. I mean, well, they're injecting their IVs most likely with caffeine to try to make it so they do not need supplemental oxygen. You're trying to make it so that they don't need that oxygen, right? Because it would mean if they don't need the oxygen that their lungs are doing well. So no oxygen or supplemental oxygen. Of course, they have oxygen. It's in the air. Otherwise, they wouldn't exist, right? So no supplemental oxygen. That's what we mean, right? When they have them hooked up to a tank or something. So no supplemental oxygen is good because that means that the baby is breathing well. And of course, that's because the baby's lungs are developing and the apnea is ending. Right? When they can breathe strongly on their own, the apnea will go away. Apnea is when you stop breathing. All right, so now let's verify our requirements. Oh boy, okay. So we have several things we have to verify. First thing we start off with is the easiest piece. It's random, right? And that we have because it said up here in the instructions somewhere that they were a random group. Oh, there it is, randomly assigned, etc. Okay, so number 1, random. Yes, it was given. Right? Done. Love it. Next, we need independent samples. All right, that is, there are 2 separate groups, right? And this is always the case. If you have a treatment with something like this, like a treatment group and a placebo group, treatment groups and placebo groups are always independent. They have to be, right? Because if you're in the caffeine group, you're by definition not in the placebo group. So I should make a note of that. So this is 2 separate groups measured once. Right? They measure them at 36 weeks to find out if they need supplemental oxygen. And I just added that as a little note. Right? Treatment and placebo groups are always separate. Always. That is mandatory. They might not always be independent, but that might be because you do a before and after thing. But this will always be, they will always be separate from each other. All right, next. Now that's the new piece, right? So this is new. We haven't had this before this chapter. But now, right, we have independent of the population. And I kind of wrote it a little bit, I wrote samples are independent of the population right there, but I'm just going to abbreviate it as independent of the population. So independent, so you have 2 types of independence to check. Okay, now to do this, we've done this for a while. We need little n1 to be less than or equal to 0.05 of capital N1. And we need little n2 to be less than or equal to 0.05 of capital N2. All right, well, little n1, we said right up here, it was 963, right? It's in the problem. So that's 963. Capital N isn't really a known value here, but we know it'd be all, I'm just going to abbreviate it, preemies, right? Preemies is an abbreviation for premature babies. It makes it so I can fit it on the page. I'm just going to kind of give myself a little space here. All right, same thing with N2. We know 954 is less than or equal to 0.05, and again, it's all preemies. Now I know it says capital N1, capital N2. Sometimes those are different numbers, but sometimes they're not. And in this case, they're not because they're, it's really all preemies. That's the pool that you are drawing from for both groups. All right, next, we need normality. Okay, so normal, because this is proportions, we have to use the bigger than 10. So you have to go n1, p1 hat, q1 hat is greater than 10. Okay, so n1, p1 hat, q1 hat has to be greater than or equal to 10. And it's always multiplication, right? When you put two letters next to each other in mathematics, that means multiply. So I put the times dots in there on the sheet. Oh, these are 2's. These have to be greater than or equal to 10. So that's a 2. Okay, well, I know N1 is 963. I know P1 hat was 0.3634 because I already found it. And I already found Q1 hat up above. It was 0.6366. I'm going to multiply these three numbers and cross my fingers that it's bigger than 10. And I'm going to do the same thing over here. 954 times 0.4686 times 0.5314. Oh, I forgot to write yes for all of these. This is yes. This is yes. And this is going to be yes. Allow me to prove it. Okay. All right, so let me go grab Desmos. Okay, so we have our values here. So we're going to take 963 times 0.3634 times 0.6366. And sure enough, that number is bigger than 10. And then times 0.4686 times 0.5314. And sure enough, both of those numbers are bigger than 10. So I just wrote in those values and confirmed that they were both bigger than 10. And therefore, we have satisfied all the requirements needed for a hypothesis test on the difference in the proportions here.